Today is Monday the 7th of March 2022 and we have a fifth day moon, an observatory, imaging system, and telescope to record it by, with the hopes of getting a better sense of our nearest planetary neighbor. Why do I say planetary? Because if the moon were all by itself in the orbit that the Earth now occupies, we'd consider it a planet. This operation is pretty straightforward. I have a Revolution 2 imager, a 4-inch achromatic refractor. I'm using a 0.5 reduction Barlow. I've got a moon in its fifth day. I've got the telescope trained, the 4-inch refractor, f10, trained on the moon, and we're going to get an image that's roughly the same as the telescope operating at about 100x. I'm using a handheld camera to image the screen, flat panel screen, 600 by 800 pixels, as the moon progresses across the screen. As the moon progresses, you should see improvement in the contrast of the image. More and more features should reveal themselves. And although I'd like it to be able to reveal the entirety of the moon on the screen, we're going to get a little bit of clipping, especially towards the northern edge as it moves across. Right now we're getting a great view of Mare Crisium. And Crisium has several craters that are located near it, as well as several other maria to the west of it in the direction of the sun. I'll check my lunographic charts, take a screenshot, and add some labels to that screenshot later, so we can all begin the process of familiarizing ourselves with lunography. So next day, I've got an image, a screen cap from the video of the previous night through the Rev2 imager. And I thought I'd take this opportunity to point out some of the chief features you'd see in, let's say, the first 5 days of the lunar cycle, which begins, of course, on the new moon, in which the moon is invisible because it's basically all in its own shadow. I believe the earliest observation of the moon is about 18 hours later. Day 5 means we're less than halfway through, so we're not to the half moon point, as you can tell from the image. But it's an excellent time to reveal and identify some of the more prominent features on the moon, which, by the way, is an extremely difficult process due to the fact that charts you may find may present the moon with north and south inverted, east and west inverted, and you have to flip the pages over and then identify the various names that are applied to objects. The surface features of the moon itself vary considerably with the sun angle. So you'll get some very high relief craters, for instance, on the terminator where the sun meets the shadow. And yet you could get complete washouts in other locations. Meanwhile, various craters all have different internal structures in terms of their chemistries. For instance, the crater Langrenus that you'll see on this chart is incredibly bright. It's obviously filled with limestone or other kinds of materials that reflect, have a very high albedo. Meanwhile, if you look towards Firmicus, which is near Undarum, Mare Undarum, you'll see that it's also partially in shadow and partially light. So making out the fact it's a crater may or may not be easily done from an image of the moon. But let's begin with something anyone can identify in the first phases of the moon. That is Mare Crisium. And as mentioned before, maria are basically upwellings of mantle substances from the moon that occurred early on after its formation. Now, there's debate about the formation of the moon, but principally its chemical signatures are very similar in terms of its mineral content to the Earth.
And it goes back basically to the time 4.5 to 5 billion years ago when the Earth was formed. So we have this issue that, yeah, it's made of the same thing, same substances, but meanwhile, it may have formed in a similar part of the accretion disk of the solar system, which means it would have drawn from the same basic materials. There's a lot of other odd stuff which relate to the moon, but rather than get into the question of whether it is actually the result of a collision between some object and the Earth, some massive object in the Earth, let's just learn our way around it a little better so we can be more intelligent in the future in any discussions we may have. Let's begin with the most identifiable structure on the moon early on, and that's mare crisium. It's that oval disk, very dark. It's filled obviously with solidified lava that was exuded from the mantle. Now, there are visible craters within the crisium, one of which is Picard, and that's very close to the C in the label on the map before you. That's crater Picard. There are several others, too, named after astronomers, Yerkes and Lick. So, and there's another crater there, I think it's Pierce. So, by just examining the internals of crisium, you can get an idea that there's a wealth of detail even within larger scale structures you may be interested in. Now, if you look at the chart, north of crisium is the largest crater Cleomedes, which is not presenting well because it's being washed out with sunlight at this point, but you can see it has some internal structure. And Macrobius. Now, Macrobius is half shadow, half light, so it's pretty well delineated there, which is probably at the 7 o'clock position from Cleomedes. Now, if we go south of crisium, you'll see Firmicus, and it's right next to a dove's footprint-shaped maria called Undarum. Okay, so we've got the region now around crisium and within it, but there are also other maria that you might want to look for early in the moon. For instance, Smithy. Smithy is 6 o'clock position right along the limb, and it's probably one of the features that waxes in and out with the moon as it presents what it's called a libration, because the moon doesn't always exactly look the same from the Earth due to its variations in the distance of its orbit. Okay, if we move on from there, let's go north instead. One of the most prominent craters you'll see north of crisium is Atlas, and it's right near the terminator, and you can see it has a central mount. Directly on a line towards crisium is Cepheus and Franklin, and yes, crater Franklin is named after the famous generalist, scientist, philosopher, politician, etc., Benjamin Franklin. Now, if you go to Atlas and you look up at about the 2 o'clock position, you'll see Endymion. You'll also see a very bright crater along the terminator, which I have not been able to identify using lunographic charts. Once again, because the presentation of different things on the moon varies with their location vis-a-vis the terminator and the limb. Okay, so if we go south from crisium, we've already introduced the dove's footprint Maria Undarum and the crater Firmicus, as well as the Maria Smithy, which is at the 6 o'clock position due south. There's a very luminous large crater, Langrenus, that is at about the 7 o'clock to 8 o'clock position from Smithy. Now, if you continue down from Langrenus in the 7 o'clock position, you'll see Vendelinus. Vendelinus is mostly in shade here. So obviously is a fairly deep object, but I also think that it's very near the Maria, that is the very large Maria, which is in that region, so it may also be complicating its view. If you continue to the 7 o'clock position, you'll see the crater Stevinus, and then finally the Rieta Valley. Now, the Rieta Valley is a very interesting thing to observe through a telescope at high power, lots of features, and it is right next to its own crater, which is crater Rieta. So that basically gives you a bit of a tour of the various things that you can look at our planetary neighbor, the moon, which, as mentioned earlier, would easily qualify as a planet by most folks' definition if it were in the orbit of the Earth all by itself. So let's go back to our videography. And as we watch the video to follow, see how many of the 14 identifiable features we've already mentioned you yourself can locate and name. And frankly, I would be challenged to remember more than 2 or 3 of them, so don't feel so bad if on this first blush all you remember is Mare, what, that round one with all the darkness and it's right there in the middle?
As per other videos of this type, the dark features on the moon, generally fairly large, are maria. They are upwellings of lava from a time when the moon was active. And the smaller, more circular regions, often with little mountains in the middle, are strike phenomena from asteroids or comets that struck the moon in the distant past. So, as the moon exits the screen and field of vision, we'll say hasta lunas, or see you later, carpe noctem.